Okay, so let's look at what we are going to get when you're differentiating the uh, hyperbolic cosec inverse of x. So if you're given y is equals to hyperbolic cosec inverse of x, what are we going to get? So let's express this as x is equals to hyperbolic cosec of y. So as usual, you differentiate both sides of what we have, but that is in respect to y. So that would be dx dy being equals to the derivative of cosec is simply okay. The derivative of cosec is minus hyperbolic cotangent of y multiplied by hyperbolic cosec of y. Okay, so meaning the expression for dy dx is equals to minus 1 over, okay, 1 over hyperbolic cotangent of y multiplied by uh, hyperbolic cosec of y. Okay, so we know what our cosec of y is, which is right there. Okay, what about our cotangent? So our cotangent, we can write this in terms of the identity. So we know that our cotangent, hyperbolic cotangent squared of y minus hyperbolic uh, cosec, okay, cosec squared of y is equals to 1. So meaning our um, hyperbolic cotangent of y is equals to square root of 1 plus, okay, 1 plus hyperbolic cosec squared of what? Squared of y. And here we can say this is 1 plus our secant squared, hyperbolic cosecant squared is equals to x here. But that is x squared. So we're going to have what? Our x squared there. Then even this part here, our hyperbolic cosecant of y is what? Is x as well. So meaning we're going to have the expression for dy dx being equals to minus 1 over 1 over, then you're going to have an x outside here that comes from what? Hyperbolic cosecant here. Then the root there, you're going to have 1 plus x squared, of which this is just simply if you are to write it in terms of u, this is minus u prime. Then here, what are we going to have? Minus u prime. Then you're going to have u, then root of 1 plus u squared, and that's what you're going to get as the expression for dy dx for um, hyperbolic cosecant inverse of x. And that's how you go about answering that question, or not really the question but proving, but we can see it as a question in some cases because that is our x there, and our x, as we said, it can be anything. Yeah, thank you very much for watching.